Hi guys, good morning to you. I am going to go over pages 3 and 4 of the homework. Obviously, you don't have to watch this video. You could have just checked with the key, but maybe this video will help you a little more. Or maybe you just want to see me because I want to see you. Today I have some tea. This cup says I'd rather be in bed. I'm going to change it to say I'd rather be in school. I hope all is well. And here goes your homework review. Okay, so which of the following is a quadratic function? So we're looking for something that's squared. Now, it's always by the highest exponent. So choice 2 might be a distractor to you, but that's called a cubic. The one with the square is called a quadratic. Cubics sometimes have squares in it, but it's still called a cubic. It goes by the highest power. Okay, so standard form, very similar to descending order. So I would have negative x squared, I would have plus 4x, and I would have plus 9. So no. The 9's not with the x, no. And no, and yes. Just double checking my choices. Okay, which of the following would be the leading coefficient? So the leading coefficient would be the one that belongs to the term that has the highest power. So the lead would be 7x squared, so the coefficient would be just the 7. Which of the following points lies on the graph x squared minus 5? X squared minus 5. So I'm going to use my calculator. I'm going to type in x squared minus 5. And I'm going to go straight to the table. And I'm looking for which of these points is on there. Okay, so minimize. I wonder if I can. Not really sure how to minimize that and still show you. So 3, negative 2, 5, 0. Let me look for those. 3, 4, 5, 20. Nope. Not you, not you. So now I'm going to go to my negatives. Negative 1 is with negative 4, and negative 2 is with negative 1. So choice 2. You could also do it without the calculator by using substitution. Okay. A quadratic function is partly given in the table below. Which of the following are the coordinates of its turning point? Okay, so the turning point always has this symmetry that goes around it. So because I have the 7 and the 7 and the 10 and the 10, the turning point has to be 0, 6. You're always looking for symmetry. Remember line reflections, symmetry? Okay. Given the quadratic function below, whose turning point is 2, negative 4, so I'm going to mark that. Which of the following gives the domain interval over which this function is decreasing? Okay, so it decreases from negative infinity until it hits 2. So we would say that the x's are less than 2 when it's decreasing. Okay? Having this little scrolling issue, but here we go. Okay. Using your calculator, create an accurate graph of x squared plus 2x minus 3. So now, since we're using the calculator, you don't have to determine the turning point, but it wouldn't be a bad idea to determine the turning point. To determine the turning point, you just need a little bit of the quadratic formula. You need x is equal to negative b over 2a, and that will give you the x value of the vertex or the turning point. Sometimes I'll do that as a little bit of scrap work just to, what did I type? Okay, let me type again. Like I was saying, sometimes I'll do that as a little bit of scrap work just so that I know where to look at on my table. Or sometimes I just go to the graph and you can see it in the graph. I love the way these parabolas look. It's like such a beautiful thing. These are the zeros right here. There's a 0 at 1 and a 0 at -3. The axis of symmetry comes right here at the -1. So when I go to my table, I want to center -1. And listen, you don't need every point. You just need a few. I generally like to take 5 points. If I can get the zeros, I'd like the zeros because they give me important information. But you definitely need the turning point. So sometimes what I do, instead of taking like 5 consecutive points, is I will take the vertex, both zeros, and then like 2 y values higher than the zeros, because it gives me just like a nice look. Okay, so I'm actually gonna go from -4 to +2 as my domain for point grabbing those points. Okay. So I have -4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. I have -3, 0, one of the zeros. I have -2, -3, and now you see this symmetry. I love the symmetry. I would still, copy all the points, but oh, what a beautiful picture. And this one's called f of x. So using your calculator, create an accurate graph. So I did that. State the coordinates of the turning point. So the coordinates of the turning point were -1, -4. And this is a minimum because it's at the bottom. So at the top, max, at the bottom, min. State the range. So for the range, you're going to find the lowest or highest, but in this case, the lowest possible y. 1, 2, 3, 4. So it's -4. So this is y's are greater than or equal to -4. Different than exponentials, because with exponentials, you didn't equal something. It was like going towards it, but never touched it. But for parabolas, they touch the turning point. The turning point's part of the function. State the zeros. The zeros are -3 and 1. And notice that's not an ordered pair. That's like a set. Over what interval is this function negative? So it's negative when it's below 0 for the y values. This is not going to have the equal bars. So it's negative, and I can use the zeros for this. It's negative from -3 until 1. And since 0 is not negative, you don't put the equal bars. Over which interval is the function increasing? Increasing is going up. So it starts going up once it turns. It turns at this -4. So it turns when x is greater than the -1. So because I'm using the x values. Over which interval is this function increasing? Okay, determine the average rate of change. Rate of change is slope. Average rate of change, they tend to use that terminology when something's nonlinear. Remember, if the average rate of change is a constant, then the function's linear. Okay, so the change in y goes from -3 until I didn't get the 4 values, so hold on one second. Where are you, my calculator? 21. Wow, that's big. Yeah, parabolas, quadratic functions, parabolas, they grow pretty fast. Gosh, I said 21, right? Right, 21. Okay, so 21. So it's from -3 to 21. So I do 21 minus a -3, which equals 24. And it goes from 4 to minus a -2, which is 6, which makes that 24 divided by 6 is equal to 4. Okay, pretty cool stuff. All right, last question. Almost done. I don't know why I'm celebrating that, because then I have to go back to cleaning my house. Okay, so g of x is shown partially. The turning point of the function has the coordinates 3, -8. So that's important. Remember, there's symmetry around it. So the -6 has a partner. The 0 has a partner. The 10 has a partner. The 24 has a partner. Find the missing outputs. Done. What is the function's b, what are the zeros? So the zeros are 1 right here and 5. Okay. What is the function's y-intercept? So the y-intercept is 10. The y-intercept can be found when the x value is 0. For the domain -1 here to 7 here, what is the range of this function? Okay, so range is low to high. So the lowest is -8 and the highest is 24. Range is low to high. So like when we're doing range, we're looking down and then up. That's range, because range is y values. Okay? All right, well, I hope this helped you. If you had any questions on your homework, please reach out if you have any questions. I am just a click away. Have a great day.